Hi, everyone. Thanks for coming to this video tutorial of the chapter A3.2 on mangroves. My name is Orly Shapiro. I'm CEO of my own company called Here and There Mapping Solutions. And I also am working with the FAO, and we use Google Earth Engine all the time. So I'm going to present to you my chapter on mangroves. I will introduce just some general concepts on mangroves, why we're using GE to help map and conserve them, and then some of the remote sensing theory, and then we'll just go through the script. I'll run it. Hopefully it runs. And if you have any questions, you can ask them after any section. So the point of the chapter is to really understand this basic workflow of how to focus an area of interest around mangroves, compile imagery, add indices, collect automatic training data, and perform post-processing. So start with an image and end up with a map of mangroves. The outcomes are mainly fusing Sentinel-1 and 2, so combining optical and radar sensors. We're going to sample points in an image and create training and testing data sets automatically. We're going to calculate some additional indices to enrich your data set. We applied automatic water masking function and a buffering to really target the area of interest on areas that will have mangroves. And what you need here is you'll have an understanding of supervised classification. We're using random forests, and this automatically derived training data. And we can look at the model and evaluate the training and model accuracy. This chapter assumes that you know how to import images and image collections, filter and visualize. This comes from part F1 of the book. You'll need to perform basic image analysis. This might be selecting bands, adding indices, computing them, and creating masks. This is part F2. We will perform pixel-based supervised classification. So from chapter F2.1, we have expressions to perform calculations on image bands. From chapter F3.1, we're performing image morphological operations, and this is from chapter F3.2. These are sort of spatial neighborhood operations. You will need to know how to create or access image mosaics from chapter 4.3, F4.3, and understand the outputs of the script, which are in some cases some histogram. For example, interpreting this Otsu's method for partitioning, which is how we perform the water mask. So let's just have a couple slides on theory. So mangroves, as you can see to the right, these are forests that live part-time in water, part-time on the land. These are tropical forests that occur mostly at the land-sea boundary, and they have major important roles ecologically and economically. They protect shorelines against natural disasters, against cyclones, the effects of climate change. They provide crucial habitat for fisheries, and because of that, a lot of the world's population really needs to depend on mangroves for their food and their income. And these are just some of the ecosystem services that mangroves provide. And luckily for us, these ecosystems are very recognizable in satellite imagery because they're wet, they're regularly flooded, so that makes them distinguishable from other types of forests. They're low elevation, so they're close to the shoreline, which makes it also easy to find where they are using a DEM, or a digital elevation model. And mangroves are unique from the other forests, often which might be affected by seasonality. So mangroves tend to have stable reflectance or stable indices throughout the year. So this makes it possible to distinguish mangroves from, let's say, other neighboring coastal forests or savannas or other tropical forests that might be nearby. So the workflow now has 6 steps. We're going to start by fusing optical and radar composites because, as we know, optical imagery has the advantage of having a number of spectral wavelengths, but then active radar can provide more information on water or on texture. So we're going to combine these to get the most of both Sentinel-1 and 2. We're going to calculate the relevant water and vegetation indices from the optical data. So you can make a lot of different combinations of the different wavelengths of Sentinel-2 data and get really more enrichment in your data set. So really more information to help drive your classification. We'll use the radar data to detect the water, where it helps detect moisture and derive these canopy textures and other indices that we want. We will determine the mapping area. So one of the main advantages is that we know where mangroves live. They have a kind of a general, let's say, limited extent where they can survive. And so we're going to use digital elevation models, water masking, land masking to basically target the area of mangrove. And that makes the process much more efficient and much more accurate. We're going to collect automatic training data from an existing global data set, which of course you can replace with any other data set you have. And then we'll perform the random forest classification, some post-processing, and we'll evaluate that model with the tools that we have. So let's go right into it. Let's talk about the steps. So the code checkpoint is here. I'll put it in the chat. So the first step is really simple. The first section 1, it's basically viewing composites and defining your area of interest. For the sake of this example, we're using the Sundarbans. It's a interesting mangrove system on the border of Bangladesh and India. It's a really easy place to map mangroves, and that's why I chose it. But you can, of course, adapt this script anywhere you want. But these mangroves are they're very visible. Beyond the border of these mangrove systems, you have extensively developed land, so you have obviously a different spectral signature. But this is a nice way to test the different algorithms. So in the first section, we're taking the optical cloud-free image composites from Sentinel-2. Now, of course, before you start the script, you will have to create these composites yourself. There's different sections of the book to help you do that. You can also use Landsat if you want. In this case, we're using Sentinel-2. I believe it was for the year 2020. And I like to use CPAL. I'll put a little plug for FAO's cloud-based Earth observation tool, cpal.io. It actually has Google Earth Engine running in the background, but it's a nice interface for performing some big data processing, and I really like using it for both Sentinel-2 and Sentinel-1 composites. So, and you can use the tools in CPAL, and then you can export everything directly to your Google Earth Engine repository. So that's really nice. So yes, the first section is looking at our optical data and our Sentinel-1 data on the right, the active radar data on the right. Now I changed the visualization parameters from the script just to make it look a little nicer here and really get those mangroves to stand out. And we can play with that when we run through the script together. So one other thing to do is to add additional indices. So we can stack the images, these different image types together. We have spectral bands. Some of the Sentinel-1 data has statistics, but it's always a good idea to have extra indices. And there's a number of different band ratios, NDVI, and different vegetation indices from chapter 2.0 that we can derive. There's also this really nice database that is also mentioned in the book, and I will also put that in the chat. And there's hundreds of indices you can combine, and a lot of them you'll find in the literature. There's people that use kind of some standard wetness and vegetation indices to complement their optical data and to add more information. So we'll add a couple indices in section 1.